Welcome back, students. In this video, we're going to cover lesson 8.4. This is triangle proportionality. So we're going to go ahead and get on into it. The triangle proportionality theorem, excuse me, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. Okay, so and then the converse to this is if two lines intersecting on two sides of a triangle separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. So what it really looks like, let's just scoot this up. So for our example over here, so they're telling us that PQ is parallel to BC. So cut these triangles. PQ intersects BA and CA. So the ratio of AP to PB is the same as the ratio from AQ to QC. Okay, so let's just get into an example. Sometimes I start sounding like Charlie Brown's mom, for any of you guys that have actually watched Charlie Brown. All right, number one, in triangle BCD, PQ is parallel to CD. So if QD is 14.5, and BP up here is 9, PC is 15, we got to find BQ, so we'll just call it X. So we're going to cross multiply like we've been doing. So this time, instead of adding, though, it's going to be this over this to this over this. Make sure everything lines up. So you'll have 9 over X equals X over, I'm sorry, not X, goodness, 9 over 15. I said it right, I wrote it wrong. Equals X over 14.5. And then we're just butterflying, just like we've been doing. All right, so 9 and 14.5, and then 15x on the other. We get 130.5 equals 15x. Divide both sides by 15, and x equals 8.7. So BQ will equal 8.7. Just don't get confused, because I know you will find BQ. Well, in this case, X and BQ are the same thing because I made it that way. All right, let's see. What I'll do is I'll do number 2, and then I'm going to leave number 3 for you guys. I'll set it up for you. Just kind of looking at the way we've been doing that. Sorry. All right, number 2. In FGH, FH and BC are parallel. So GB, it's over here, it's 14.4. BF, that's down here, so that's 4.8. On the other side, it says GH, so the whole thing's 21. Find GC and CH. So let's just do this. We'll do, we know the whole thing is 21. So this one's going to be 21 minus X, and we'll make CH X. And then we'll cross multiply. So it'll be this over this, this over this. So let's go over here. So we'll do, let's see. So we can put X on top. We're going to start here. So we're going to go 4.8 over 14.4 equals X over 21 minus X. And I know you're like, well, why didn't you do it the other way? Well, we can do it either way. I just wanted X on the top, but just understand you can write it both ways. And now we're going to cross multiply or butterfly, whatever you like. Excuse me. All right, so 14.4 and X make 14.4X. That equals So we're multiplying 4.8 times 21, which is 100.8, minus, hold on oh yeah, 4.8x. Sorry, I got a little lost a minute. All right, so now we're going to solve for x, and then that'll give us what we need to know. All right, so we're going to add 4.8x to both sides because we had negative 4.8x here, okay? These cancel. This is 19.2x equals 100.8. Divide both sides by 19.2. You get that x is equal to 5.25. So CH, I'll just write it over here, is 5.25. And then they wanted GC. And then GC was 21 minus 5.25. So we'll write it here, 21 minus 5.25, which is 15.75. So GC is 15.75. We'll put them both over here. All right, so for the bottom, get this set up for you. You're going to do it just like we did here. So, all right, it says NWXY, YL equals 5, and XL equals 20. And it says JX is 4 times as long as this. All right, there's WJ. So WJ, remember, if we get anything like that, so we'll make the smaller guy X, the bigger guy. So JX is 4 times. So he's 4X. Okay? So there's your proportion. Set it up, and if it equals out, then that's going to make these two parallel, and that's going to be your reasoning. So go to it. Flip it over. Now, excuse me. This section has an extra side, so a little bit longer section, especially compared to the last two were pretty short. So, all right, mid segment of a triangle. The segment that connects the midpoints of the two legs of the triangle. Each triangle has 3 mid segments. So this is a mid segment here, this is a mid segment here, this is a mid segment here. The mid segments of triangle ABC are RP, PQ, and RQ. See? All right, so triangle mid segment theorem. A mid segment of a triangle is parallel to one side of a triangle. So, like the mid segment here is going to be parallel to one side, or if it was this way, it would be parallel to that side. The mid segment's length, okay, this is the important part, is half the length of its parallel side. So mid segment's length is half the length of its parallel side. All right, so for this, it says J and K are midpoints. J and K are midpoints. So FH, and let's see, of FH and HG. All right, so if JK is parallel to FJ, then JK is going to be 1/2 the size of FG. So again, if these two are parallel, these two are midpoints, this guy's going to be half the size. This guy's going to be half the size of this guy. So just so we know that this is the mid segment and this is the leg. Just want to make sure we're all on the same page. All right, proportional parts of parallel lines. Peter Piper picked a pack of pickled peppers. There's your bonus for anybody that's listening. Peter Piper. Anyway, so proportional parts of parallel lines. If 3 or more parallel lines, so 1, 2, 3, are cut intersect two transversals. So like here, this is kind of like we talked about before, but instead of just 8, there's a lot more. Then they split the transversal into proportional segments. So in this case, if AE is parallel to BF is parallel to CG, then AB over BC should be the same as EF over FG. They should be in proportion. All right, and then congruent parts of parallel lines. So if 3 or more parallel lines split a transversal into 2 congruent segments, so like they're showing here, wait a minute, split into congruent segments, then they also split any other transversal into congruent segments. Okay, sorry, I got lost in the words a minute. So in the example, if they're all parallel like we talked about before, then AB is congruent to BC, or then these guys would be congruent. So if these 3 guys are parallel and these 2 guys are congruent, where'd my pen go? Then this guy would be congruent to this guy. That's what all that says. This is important when it comes to these triangles. You'll see it's tough to make everything make sense until we start actually practicing. So in the figure, EF and DE are mid segments of ABC. So these guys, this is a mid segment of this triangle, and this is a mid segment of this triangle. Okay. So list any mid segments. Well, they told us. FE or EF, we'll just write it like they did. And DE. So easy enough. Mid segments, they told us right here. All right, so find DE. All right, so let us see. All right, so DE is this guy, and he is half of this guy. And this guy's 15. So DE, 1/2 of AC. And then 1/2 of AC AC is 15. So DE is 7.5 because it's half of this. It's half of this and half of those. These each be. So each of those is 7.5. This is find AD. So AD is this guy. This one's 9.2. AD is going to be double or 2 times EF. And that's 2 times 9.2, not 19.2, excuse me. Actually, AD, I'm looking at it. What am I doing? Yeah, AD is the half. So it is equal to EF. So it's 9.2. This is 9.2. This is 9.2. I got confused at what I was looking at. This whole thing would be both, but so yes, because this is 9.2, that's 9.2. All right. Just a second. Oh, and there's another part of the problem. That was what I was missing. All right. So find X. So here's our. Now so we're looking for this angle. And we have this angle. So if these guys, remember the mid segment and the third side of the triangle are parallel. So if these guys are parallel, this would be to the right of the parallel, below the transversal, to the right and below. So X, wait a minute, so hold on. because AC and DE are parallel, angle EDB is congruent to angle CAD. Therefore, X equals 82 degrees. All right. Hopefully that made sense. Ah, goodness. All right, backside. And after this, only one more section in this module, and we are done. We'll be done with 8. We go back to 7 now. Okay, backside of, or third page of 8. In the figure, FG, GH, and FG. Lord. FG, GH, and it says FG, but that's not right. It's FG, GH, and FH. Oh, goodness. Didn't see that. Okay. Let me mark that on my paper here. I forgot. CFH. Okay. Yeah, FG, GH, and FH, or you could say HF, whichever, are mid-segments. They want us to find AC, so that's this whole line, AB, this line, AH, this line, which is going to be half of AB, and then find X. Okay, so AC. So let's see, what are we... All right, so AC is going to be, this is the mid-segment for AC. So AC is going to be 2 times GH, because that's its mid-segment. All right, so 2 times 16.25 means that AC is going to equal 32.5. Okay, because it was this. So this thing is 32.5 from here to here. Remember, these are halves. So this is 16.25. This is 16.25. So if this guy is double, or if this guy is double this guy, and we know these are halves, so this would be, so for AB, I'll just do it this way because I don't want to confuse you guys. AB is going to be 2 times of FG. FG is 19.5. So 2 times that is going to be 39. Oops. 39. So this guy is 39. Well, remember, these are halves. So this half, 19.5. This half, 19.5. So find AH, it's 19.5. And then find X. Well, before we go further, let's look to this side. So again, this is the mid-segment. This is double the mid-segment, and these guys are congruent because that splits it in half. So if this is 14, this is 14, and this is 14, the whole thing would be 14 plus 14, which is 28. So just notice that. It was these two were this, these two are this, and these two are the same as this. All right, now this angle. So what angles do we have? We only have this one, but remember this and this would be parallel. This is going to be above the parallel line to the right of the transversal. So X, so this is CFG. CFG is going to be congruent to CAB because they're alternate. Well, no, I'm sorry, they're corresponding angles. All right, they're corresponding angles. So, because this one equals 41 degrees, the other one equals 41 degrees. And that means X equals 41 degrees. Okay. Gonna do the next one, and the bottom I'm gonna leave for you guys. going to be straightforward just like we've been doing, so you should have no problems. So find the values of x and y. Now remember, we can't find these guys together, so we have to find them separately. You'll notice x's are together, y's are together. Let's see. And also, it's kind of, this print is kind of off, but these two guys are congruent. So what we're going to do is solve for y, because we know that these are congruent. And so all we have to do to solve for y is put them equal to one another. And once we solve for y, then we go our proportions. We'll go this guy over this guy. I'm sorry. It'll be this over this to this over this. So let's subtract y from both sides. 3y minus 1 is going to equal 8. Add 1, add 1. 3y is going to equal 9. So y is going to equal 3. All right, so this is going to be 3 plus 8, which is 11. This is going to be 4 times 3, which is 12, minus 1, which is also 11. Good thing. So if these two are congruent, now we can solve this way, because these two should be congruent, because the congruent parts of the parallel line rule from the previous page. So let's put these equal to one another. All right, minus 2x. And we're going to go ahead, so we get rid of this. We're going to go ahead, we want 12 over here, so we're going to add 12 to both sides. And then I'll pick it up over here. So these cancel. 7 minus 2 is 5x. 8 plus 12 is 20. Divide both sides by 5, and x is going to equal 4. All right, so down here, just check your proportions and solve for x. If you have any questions, please let me know. Send me a message in Focus or on Teams. If you found us by mistake, I'm sorry, or I hope I helped you. Consider subscribing and to the channel. It helps. Till next time, have a good night.